Welcome to Jarnac Tutorial 2, Modeling a Simple Branch. In this tutorial, we will study some of the basic properties of a simple metabolic branch and introduce the notion of a pathway flex. We will begin by defining our pathway P. We will then declare our species. Our fixed species will be x0, x1, and x2, and our floating species will be s1. We will then define our reactions. There will be a uni-uni reversible Michaelis-Menten reaction between x0 and s1, and two more leading from S1 to both X1 and X2, forming a fork. We will then set the parameters and variables. The concentration of X0 will be set to 10, and the other concentrations for the species will be set to 0. All of the reaction parameters will be set to 0.1, except for the Vmaxes, which will be set to 1.5, 2, and 4 for reactions 1, 2, and 3 respectively. To make sure the script is running correctly, we will calculate the steady state and print the results for the steady state concentration of S1. Your output for S1 should be 0.0314073. We are now going to introduce the notion of a pathway flex. At any time during the evolution of a pathway, the rates through the different reactions as well as the species concentrations will evolve in time, eventually setting to some steady state values. The reaction rates that we measured during a simulation are termed fluxes. To display this data, calculated by ss.eval, we can add the following lines which will print the flux information. In each case, we will print the name of the flux, followed by the value of the flux. Running the script will show the flux values in the console window. Another way to print this data is to use the console and enter the rs method, which returns the name of the reactions, and the rv method, which returns the reaction rates, the fluxes. This concludes Tutorial 2. In Tutorial 3, we will look at modeling a simple cycle and introduce the idea of parameter scans.